Okay, Assalamualaikum, and we continue our lecture. Okay, now we are going to discuss by using of null hypothesis to comparing the precision of two measurement or two person from the data given from the two person or two measurement or two method. So we call it as a F test. And before this we already discussed comparing between mu and x and x for t-test. Now we're using f-test. So we want to check, is method A or measurement A more precise than method B or measurement B? Or we can say also person A and is more precise than person B. We want to check. Or maybe actually that two person or that two method actually is a precise. The precision is equally. So is there any significant difference between both methods? So we use f-test. So this is the formula we use in the f-test. This is the standard deviation, this is the variance. So the standard deviation, the power of 2 divide the power of 2 for method, let's say this is method B and then method A. We cannot simply put method A here, method B here. We have to know. And how? But before that, with the degree of freedom and N2, our H0 in the F-test is the precision is identical, means we said maybe the precision or the standard deviation from the two method or measurement is equal. That is our H0. For example, if you look here, let's say the result come out from method A or person A versus method B or person B. Let's say the result come out. This is the standard deviation for person A or method A, and then this is the standard deviation for person B. Based on this, maybe we can simply say this is more precise. No, we cannot simply say this is more precise. We have to confirm by using f-test. Okay, how to use f-test? If you look from these two number, this figure, which is the higher? So the higher is this one. So this one become numerator. Because this is the lower, this one become denominator. So to calculate F calculation is the standard deviation power of 2 for numerator divide standard deviation for denominator. So based on this, we can say this is numerator and then this is denominator to calculate F calculation. Whatever comparison, if this is higher than this one, this is become numerator. So what is the F calculation for this? It should be F calculation 0.035 the power of 2 divide 0.027 the power of 2. So this is our F calculation. To calculate F calculation, we must know this is numerator, this is part for denominator. So which one become numerator if their standard deviation is higher other than that? Okay, so this is our numerator, this is denominator. So we get the F calculation. And then we compare with F table. Now how to compare with the F table? If you look at the F table here, we have denominator here and then there is a numerator. So what is the F table value? To get, we must know what is the replicate number for numerator and also replicate number for the denominator. So because this one become numerator, so their replicate number is 4. for this one, denominator, their replicate number is 5. But to get the correct value, we must look at the degree of freedom. The degree of freedom. So, to get the F calculation, F table from this, the F value from this table, by using this example, we must look at the 3. Why? Because the degree of freedom here is a 4 minus 1, 3. This is numerator, and then this is denominator. So we look numerator number 3, and then denominator is number 4. Then we get here 6.59. So we get the F calculation, F table. So the F table is 6.59. So we compare this value with this value, which is higher. If we found our F calculation is lower than F table, then we accept the H-null. Means actually these two method or these two person give same precision. This is the meaning of F table, and this is how to use. Okay, look at this example. You can look by yourself and how to use this. And this is the example. You look by yourself, and then if you don't understand, then you can ask me. Okay, thank you.